Hey everybody, let's give this problem a try. So it's a frame with distributed loads. So how do we do this? You don't have to, but a good starting point is just take the entire structure, whatever it looks like, entire structure as a whole, and then just draw the reactions at the supports. So there's a pin over here and here. Let me pick coordinates. Okay, so I'll just decompose the reactions at pin A into X and Y components. The reactions at pin F, I'll decompose into X and Y components. And then there's a load up here at the top. What is the magnitude of that? It's the area of this shape. So that's a rectangle, 2 by 2, so 2 this way and 2 this way, so it's 4. Okay, and then there's a load here. The area of this shape, it's a triangle, so 1/2 base times height, so that's 3. And where is it acting? So it's at the centroid of the shape. So 1/3 of the way this way, which is 1 meter, right? And this way is 2 meters. And then for this one, the centroid of the rectangle, which is just halfway, right? Okay, so here's the free body diagram of the entire structure. And then we can write some equations. So in the x direction, we got, let's see, AX, Fx, and the 3 kilonewton load. In the y direction, we got AY, Fy, minus 4 kilonewton. That's it. Okay, and then that's some torque about. Somewhere clever where we can get rid of unknowns. So either here or here. How about at point A? Okay, so there's torque in the positive z direction from Fy, 1 meter, 1 meter, Fy. There's no torque from this or this or this. And then there's a torque in the negative direction from this, so negative 2 meters times 3 kilonewtons. And then from this in the negative z, negative 1 meter, 4 kilonewtons. Okay, so we have 1, 2, 3, 4. 4 unknowns, 3 equations. So it's statically indeterminate. We can definitely solve for Fy. So we got Fy. We plug it in here and we can solve for Ay. Okay, so we can solve for Fy and Ay, but we don't know Ax, Fx. We know they're related, but we don't know the actual value. We don't have enough equations. Okay, so what do we do next? For a frame, you break it apart. Okay, so to break it apart, let me make some space. Okay, so we break it into its different parts. So there's that vertical bar, and then there's the horizontal one on the top, and then the diagonal one over here, this one, and then the other diagonal one over here. Okay, and then there were the reactions at pin A, the reactions at pin F. There is the distributed load here and the distributed load here. How much was that now? That was 4 and 3. Okay, and then when we break it apart, it shows the reactions between. So for this one, there's a pin here and a pin here. So it's definitely a 2-force member. So it's either in compression or tension. We'll just pick one. And let's see, this is C and E. This is C, this is E, but they're equal. I'll just call them both C, same magnitude. Okay, and then for this one, there's a pin here and a pin here. So this is also definitely a 2-force member. So let's just say, since I already labeled it like that, for sure the force over here is equal and opposite this one, and the force here is equal and opposite this one. For sure, it has to be. It's a 2-force member. Okay, and then where else do we have? For this one, this point is connected to this point. So this is equal and opposite. So these are equal and opposite. And let's see, this is 1 meter, 1 meter. Okay, so that's 45 degrees. And then, where else? Oh, over here. This is connected to this. So this is C over here. This is the same as this, equal and opposite. And then point B here is connected to here. So I'll just draw these equal and opposite. So like this and like this. Okay. And then again, let me point out, right? This is equal and opposite to this because of Newton's third law. This is equal and opposite to this. This one is equal and opposite to this. And then there's also pin D up here. So I'll label that here. Just call it dx, dy, and this has to be equal and opposite to this. Okay, there we go. I think we got, let's see, there's A, B is over here, C is over here, D is over here, E is over here, which is over here, and then there's F. Okay, so we got everything. Okay, so let me point something out that we already know this answer and this answer. And that's important because you see this bar, it's at 45 degrees, right? We know this angle right here is 45 degrees, which means these have got to be the same magnitude, right? And we actually can solve for that. So I'm going to draw it instead. So we already know this answer, Fy. So I'm just going to draw it like this instead and make note that Fy is this cosine 45. Okay, so instead of like that, I'm just going to draw it along the axis. And this is known, known, which means this is also known, right? Because this is a 2-force member. And then, instead of drawing it like this, I'm going to draw it equal and opposite. Okay. And if I can get that arrow over there. Okay. Like this, because this is at 45 degrees. This is also at 45 degrees. And now this is known. Okay, so that helped a little bit. Now, let's see, what should we do? For each of these, okay, let me make a little bit more space again. Okay, so for this member, we can write at least these equations, and then we can sum torque about somewhere. For this member, similarly, we can sum forces in x, sum forces in y, sum torque about somewhere clever. So let me just write these first. So x direction, minus dx minus c cosine 45. This is 45, right? And that's it. In the y direction, minus dy minus c sine 45 minus 4 kilonewtons. Okay, and then let me go over here. So x direction, dx plus, and this is 45 right here, right? C cosine 45, and then this is also 45, plus f cosine 45 plus ax. Okay, let me just move this. Is that everything in x? Yes. Okay, y direction, dy. Oh, no, I missed the 3 kilonewton load right here. Plus 3 kilonewtons. Okay, y direction, dy, c sine 45 minus f sine 45 plus ay. Okay. Now, is there anything we can solve immediately? Also note that we already know this answer. So what should we do now? We have 2 more equations we can write. How can we be clever about it? If you look at this equation here, there are 3 unknowns. So if we write another equation, we should get rid of either one of these 3, which would be cleverest. So for example, if we sum torque about point D, then what does that give us? There's no, I'll just write it, right? So sum torque about point D would be negative 1 meter times 4 plus c sine 45. That's it. Right? So then if you look at this, oh, let me underline, right? There's just one unknown here, which means you can solve for c. And then you plug that in here, solve for dy. Plug that in here, solve for dx. So that means, after we do this, we know all 3 of these numbers. Okay, now let's go over to the next member over here. Now we know c, dx, dy. Right, so what's left? There's only one unknown left. Right, so we know c, dx, dy. We already knew f. Okay, so there's only one unknown left here, ax. So we don't even need to write another equation. We're good. Just solve this for ax, and we know everything everywhere. Okay, so that was helpful. Keep practicing this type of problem. So this is a good one because there are distributed loads, and it's a frame where you have to do that strategy where you break it apart. Okay, so let me know if you have other questions about this one, and I'll see you on the next video.